So we continue with the physical properties, and as you know, we are doing melting points and boiling points of haloalkanes. Now another very important thing to remember here is that we'll be learning about the melting points and boiling points in isomeric alkyl halides. Let's see what is the trend. What is an isomeric alkyl halide? In which all the examples I'm going to write here, they will have the same molecular formula, but they will have different structural formulae. Let's see how it changes and which examples we are taking. The first one I'm going to write is CH3, CH2, whole 3Cl. This is 1 chlorobutane. 3 carbon atoms, 1 carbon atom, हो गए 4. The next one is CH3, whole 2, CH, CH2Cl. It's just an isomer. Let me just open it up for you. This is CH. इस पे यहाँ एक CH3 है. CH3 is here and CH2Cl is here. Right? It is again 1, 2, 3, 4, but it is an isomer of butane. The other one that we are going to write is CH3, CH2, CH, Cl, CH3. This is 2 chlorobutane, right? And the last one will be CH3, 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 Cl, tertiary butane. All of them, look at all the 4 formulae. 1, this is the same, 2, 3 and 4. तीनों के तीनों butyl chlorides है, but there are 4 different isomers. And if I write down the values are like this. This normal butane is 351.5, normal chlorobutane. Then this is 342. This is 341. And the last one is 324 Kelvin, सबसे कम. So what is the trend? What do you have to remember here? When you speak of isomeric alkyl halides, what happens? The boiling point decreases with branching. This is what you remember. Boiling point decreases with branching. Why does it happen? Again, I told you boiling point and melting point के लिए main parameter क्या है? Intermolecular interactions. When branching takes place, what happens there that the magnitude of those intermolecular force of attraction decreases. There's a hindrance. There is so much of branching here that another molecule के साथ interactions इस polar bond का करना, there's a hindrance in that. Since that happens, there's a decrease in the intermolecular force of attraction. There's a decrease in their boiling points. Look at this. This is 1 chlorobutane, straight chain है. Polar bond जो इसमें CCl bond है, एक molecule का can have very easily interactions with the polar bond of another molecule. That is why the boiling point is 351.5. So again, quickly summing it up, in isomeric alkyl halides, boiling point decreases with branching because with branching, intermolecular interactions decrease. Right? And I'll write down the final trend in this. We're talking about melting points and boiling points of haloalkanes. I'll just write down the examples first. For example, I have CH3Cl. Then I have CH2Cl2. Then I have CHCl3. Then I have CCl4. These are all the derivatives of the same parent alkane. What is that parent alkane? CH4, methane. But this is a monohalogen derivative. This is a dihalogen derivative, trihalogen derivative, chloroform, tetrahalogen derivative, carbon tetrachloride. And if we write down their boiling points, this is 249 Kelvin. This is 313 Kelvin. And this is 334 Kelvin. And this is 350 Kelvin. Now that if you have to draw a generalization, what will be that generalization? For a same R group, we are not changing R, alkyl group is the same. Boiling point increases with increase in the number of X atoms. Preferably those X atoms are also same. We have taken chlorine in this example. Why? Because in this you just have one carbon CCl polar bond. You have two polar bonds here. You have three polar bonds here. You have four polar bonds here. Since the number of polar bonds is increasing in this direction, the number of polar bonds is increasing, the magnitude of intermolecular force of attraction will increase, leading to the increase in the melting and boiling points. Right? These are some very important points about the boiling points of, particularly boiling points. Generally जो trend होता है boiling points का, वही trend melting points का भी होता है. And these were the melting points and boiling points of haloalkanes.